All right, let's learn how to name ionic compounds. So remember, ionic compounds are compounds that are made up of both a metal and a nonmetal. You can see this here. Our metals are going to form positively charged ions. Our nonmetals are going to form negatively charged ions. And then we're going to put them together to bring together our ionic compound. Now, to reiterate, all the metals in group 1, when they become an ion, will have a +1 charge. The metals in group 2, your alkaline earth metals, they will all have a +2 charge. Group 3, aluminum, has a +3 charge. And then we'll talk about the rest of the metals in a few minutes. Okay, so let's talk about naming them. When I name my ionic compounds, I name the metal first. The metal's always written first. So we're going to take this compound, which we've looked at already, sodium chloride. The metal is always named first, and it just holds its elemental name. And then your nonmetal is what we named second, and it ends in "ide." So Cl is chlorine, right? But it's going to be chloride. So this would be sodium chloride. You go here, all right, we have potassium chloride. So the metal holds its elemental name, and the nonmetal ends in "ide." So you drop the INE from chlorine and change it with IDE, chloride. Here we have calcium oxide. Calcium oxide. Okay, so let's look at a couple examples. Let's start here. Let's name it. I have calcium is our metal, and it holds its elemental name. And then instead of bromine, it's going to be bromide. Okay. All right, let's look at another one. Here we have Ag is silver. N will be nitride, so it will be silver nitride. Now, you may ask why we're not concerned about the numbers, the subscripts. We don't use these subscripts in our naming for our ionic compounds. The reason being is because they're there because of the charges. So calcium is in group 2, so it has a 2+ charge. Bromine, or bromide, it's in group 7. It has a -1 charge. So for me to put these two together, you can either crisscross your charges or look at the fact that you need 2 bromides to counteract this 1 calcium. So calcium bromide is always going to have the chemical formula of CaBr2. Same thing is true here. Silver actually is always +1. That'll be one of the ones we'll go over in a few minutes. And the nitride is in group 5, and it's a -3. So I need 3 silvers to counteract this 1 nitride. That's why that 3 is there. Okay. Now, we've talked about group 1 metals and group 2 metals. And then we've talked about aluminum. Then we have that whole big section in the middle of the periodic table known as our transition metals. Our transition metals can have several different charges. For example, iron can have a 2+ charge or a 3+ charge. So our transition metals need a way for us to distinguish which, in this case, which iron we're talking about. So our transition metals are called multivalent metals because they can have more than one type of charge. We're going to end up representing them with Roman numerals, and I'll show you this in just a second. All right, so that whole block, that whole transition metal block, they can have more than one charge, with exception to zinc. Zinc is always 2 plus. And then the metals that fall under the staircase, the inner transition, or the metals that fall under the staircase to the right of the transition metals, the only other one that is consistent is silver. Silver is always +1. Those two are never going to change. And what I mean by the ones that fall under the staircase to the right of the transition metal block, we're looking at ones like lead, tin. Okay, so this is what we do. We're going to use Roman numerals to distinguish which charge we're talking about. Copper has 2 potential charges, copper 1 or copper 2. Okay, and so we're going to represent that. If it's copper 1, we'll do copper 1, Roman numeral 1, copper 2, copper 2. So this tells us what the charge of the copper is. Now, when I name them, I have to include that in their name. It's still going to be the name of the metal, followed by the charge of the metal in a Roman numeral, and then the ide. So whatever your non-metal is in the ide. So let's look at how I figured this out. We're going to start with this one. All right, so copper, I just have this. I recognize that copper is a transition metal, so I know it needs a Roman numeral. How I find out what that charge is really based on what it's bonded to. Oxide, we know is in group 6, and it carries a -2 charge. I have 1 copper here, so that 1 copper has to have a 2 plus charge in order for them to balance out to be neutral. So then the name of this would be copper 2 oxide. The other one here, okay, same rules apply. We know oxide is always 2 minus. So what's copper going to be here? It has to be +1 because there's 2 of them. So copper, if I have copper +1 but 2 of them, that will balance out here. So that's where we get copper 1 oxide. If I didn't have the Roman numerals, they would both be named copper oxide, but they are 2 different compounds. Here's a chart for you that shows some of the different transition metals with different charges. You don't need to worry about this list of older names. We're not going to actually, I'm not requiring you to know that. But these are just some ideas of how they can have different charges and what they are and how you would name the ion. All right, so let's go to determining the charge like I just showed you with copper. All right, so we're going to start here with chromium, CrBr3. Okay. Now, chromium we need to recognize as a transition metal. Therefore, because it's a transition metal, it's not in group 1 or group 2, it needs that Roman numeral. So, and I know that the compound itself is neutral. So I need to look at my nonmetal. My nonmetal here is bromide. And if bromide's in group 7, so it's a -1 charge. And I have 3 of them. So overall, it's a -3 charge. I only have 1 chromium, so that 1 chromium needs to fulfill that total +3 charge. So the name of this, so chromium has a +3, the name of this would be chromium 3 bromide. Okay, let's look at another one. We have SN, which is 10. That's terrible. And then chloride, so SnCl2. 10 is a transition metal, and so we're going to look at chloride. Chloride is just like bromine, it's in group 7, so we have a -1 charge, but we have 2 of them, So overall, on the nonmetal side, we have -2. There's only one 10, so it has to carry the whole 2 plus charge. So that gives me 10 to chloride. Okay, let's look at these. All right, we've got lead and chloride. Lead is a transition metal. So we're going to start here. Chloride, it's in group 7. It has a -4 charge. Excuse me, a -1 charge. I have 4 of them, so 4 times -1 is a -4. So total charge on this side is -4. I only have 1 lead, so that 1 lead needs to carry all +4 charge for it to be neutral. So then I would name this lead 4 chloride. If you don't have that Roman numeral, it makes it incorrect. Okay, let's look at this one. We have iron, which is a transition metal, and then sulfide. So sulfide's in group 6. Group 6, just like oxygen, carries a -2 charge. So here, iron has to be +2, because there's just one of each. So I would name this iron 2 sulfide. Sorry, this mouse isn't working that great. Okay. All right, on the flip side here we're given the name and we're asked for the formula. So this is telling me that, oops, let me try that again. My metal has a +4 charge. Okay, and then I know what oxide is. Oxide is oxygen to the 2 minus. So now I'm going to put these two together. I need 2 oxygens to balance out that 1 metal. So it would be RuO2. Okay. Another type of ionic compound is one that includes what we call a polyatomic ion. A polyatomic ion is a group of atoms that are bonded together covalently but hold a charge. For example, here, NO3 to the -1. So this nitrogen has 3 oxygens covalently bonded to it to the -1 charge. For polyatomic ions generally end in either ate or ite. These in particular are called oxyanions. Anions mean they have negative charge. The oxy part is that oxygen is included in them. So one thing I want to point out here is if I have nitrogen, and it's just an ion, I have nitrite, right? Or excuse me, nitride. So that's nitride. This nitrogen carries a -3 charge. Here, let me do that again. Here, I have NO3 to the -1. This here is treated as one thing. So this here is treated as one thing. That whole thing has a -1 charge, just like this one nitrogen has a -3 charge. There's a pattern for these when it comes to naming. You'll be given a chart with these, so you don't necessarily have to memorize them. But I have NO3 to the -1, that's nitrate. NO2 to the -1 is nitrite. When I lose an oxygen, I go from ate to ite. Here, SO4 2 minus sulfate, lose an oxygen, SO3 to the 2 minus, it's sulfite. In addition, with oxyanions, here's a list of not only just losing one, but more than one. All right, so here's kind of our let's start as this is our base. Our base we're going to start is chlorate, or 8. So ClO3 to the -1 is chlorate. If I lose 1, ClO2, it takes on ite, so chlorite. If I lose another one, then I add hypo to it. ClO to the -1 is hypochlorite. And then if I go back to the base, but I add 1, it takes on per. So this would be perchlorate, ClO4 to the -1. And you'll see the same pattern here with bromate. Okay. Polyatomic ions, again, contain a group of atoms that are bonded together covalently, but they hold a charge. So we're going to name them. We're going to learn how to name them now. And we're going to do it the same way. For the most part, all of your polyatomic ions are going to be an anion. So they're going to take the place of the nonmetal. We're going to keep the naming the same. It's still an ionic compound. This, your metal, is going to hold its elemental name. And then whatever this polyatomic ion is, that's the name it's going to hold. So you're going to look at your chart right now and say NO2, that's nitrite. So this would be sodium nitrite. Here's a list. So I encourage you to print this out or have this open in your book. You'll use this quite a bit. So these are just common polyatomic ions, and you'll notice all but one are anions. The only positively charged one is ammonium. This, when put in a compound, will take the place of the metal. Everything else takes the place of the nonmetal. Okay, so keep this chart and let's look at a couple examples. All right, let's look here. So I'm going to cut this in half. So I have potassium, NO2 is nitrite, potassium nitrate. Here, calcium, SO4 sulfate, calcium sulfate. Here, magnesium, NO3 is nitrate, magnesium nitrate. Now, I do want to show you real quick where these formulas come from. Let's start here. So if I gave you potassium nitrate and asked you to write the formula, you would know that group 1, potassium, is +1. You'd look at your chart, look up nitrate, and you'd find it's NO2 to the -1. So to write the formula, you just put those two together, right? They balance each other out. So KNO2. Same thing is true with calcium sulfate. If I gave you calcium sulfate, calcium, sorry about that, has a 2+ charge. You'd look up sulfate on your chart, and it has a -2 charge. Those two just go together, calcium sulfate. But this one, we have magnesium. Magnesium's in group 2. And then you would take your chart, look up nitrate, and nitrate has a -1. Oops, sorry about that. -1, -1, a -1 charge. So 2 plus -1. So what do I need? I need 2 of these to balance that out. So when you need more than one polyatomic ion, you need to put the polyatomic ion in parentheses. So I'm going to write my nitrate, and then I'm going to put my 2 on the outside of the parentheses. Okay. All right, so here we go. How do I even know I have a polyatomic ion? It's more than two atoms. I can always assume that when I see it. All right, so let's see here. I have lithium, and then what's Cr2O7? Go ahead and look it up. So this would be lithium dichromate. right? Here I have 10, but what's 10? 10 is a transition metal, so I'm going to have to include a Roman numeral. But we'll look here. I have ClO3. If I look that up, it's chlorate, and it has a -1 charge. I have 2 of them. So that means 10 has to have a +2 charge. So I would name this 10,2 chlorate. And again, you're not expected to memorize your polyatomic ions, you just got to know how to use them. Okay. So now we're going to we're going to write the formula. So cobalt is CO. This is telling me it has a 2+ charge. I'm going to look up phosphate on my chart. Phosphate is PO4 to the 3-. So how do I put those two together? I'm going to need 3 cobalts, right? Because our common denominator here is going to be 6. So I'm going to need 3 cobalts, and I'm going to need 2 phosphoruses. 2 phosphates. But because I need more than one of my polyatomic ions, the polyatomic ion needs to go in parentheses. So CO3 parentheses PO4 2.